I'm Wei. I also work for Astronomer. And our title don't necessarily need to be this lengthy. So it's basically you use Ruff to do Airflow 2 to 3 migration. And before everything started, you can scan this QR code to get the link to the slide deck. And if you found out it's a PDF with 1,000 pages, you have one good news and one bad news. The good news is you are using the right link. And the bad news is, it's actually 100 pages. So let's keep going. What to expect? So first, I'll talk about Ruff, linter, formatter, and what it is really quick so we can make sure everyone's on the same page. And the second thing, I'll talk about how we can use Ruff to do Airflow migration. So, the third thing, how this is done. We'll go through some of the Ruff source code to see how we implemented all these kind of rules. So what is Ruff? Ruff is a Python linter. So what is linter? Linter is a static analysis tool that checks for your coding style or potential like error or something like this one. This is not actually an error, but it's a bad coding style because you're using an exception tuple, and Ruff will tell you just don't do it. You should use like not divided by 0 error or something else more concrete one. If you go to the Ruff official documentation, it will tell you what each rule does and why is this a bad practice. And it's just as bad as using Airflow exception. I know we still have some Airflow exception in core and Airflow provider, but we're trying to deprecate it, so don't use it if possible. And Ruff is also a good code formatter, so you don't need to fight the coding style with your colleague anymore. Like before, this is technically a Python code that works, but it's barely readable. So with Ruff, we can just format it into a more readable format. And then let's go to the Airflow migration itself. And we got some press from community. Upgrading is quite painless only to all the automated tools such as Ruff inspection. Yes. And I actually used this tool to migrate the PyCon Taiwan Airflow instance from 1.10.15 to Airflow 3. And this is the specific commit I use the Ruff Airflow rule to modify our code. So basically, it remove Airflow decorator, import dag and task, and replace it with Airflow SDK, which is the path we should use now. And this is the command we should use. And if you know there was a -- preview flag, it's no longer needed because in Ruff 0.13.0, these few Airflow rules already being stabilized. So you can skip the preview flag. If you don't know the preview flag, you don't need to know it now. And then you can run Ruff with UV if you don't know UV. UV is basically a tool. You can run any kind of Python command line tool easily. And then we'll run Ruff check to check whether there's anything wrong in example.py. And then the select flag tell Ruff what rule we want to choose. And the ones start with AIR is Airflow rules. And with the fix flag, Ruff will try to fix if there's a fixable solution for these rules. If you go to the official Ruff document, the AIR part, it's the first rule because we start with A. Nice naming choice. And there's a toolkit emoji there. If there's an emoji there, it means part of the rule is fixable. And there's an unstaff fixes flag. It might sound a bit dangerous, but let's go to the Ruff documentation again. So what is a staff fix? So the staff fix means it preserves the original runtime behavior, and unstaff fixes might change some of the runtime behavior or remove your commands and something like that. But for our Airflow rules, they are mostly just fine. They are trying to modify your import path, and that's it. So unless you are doing things really dynamically and weirdly, most of the cases should be fine. They are as staff as their staff fix counterpart. And that works through all the rules we have now. We currently have 6 rules. And our current convention of AIR rule is AIR XYZ. And the X means any airflow version higher than that X should be able to apply to these rules. So airflow 001 means every airflow should follow this rule, and airflow 302 means airflow 3 something something should follow this rule. So let's start with the best practices. They are not related to migration, but yeah, why not? So 001 means that your task variable name should match your task ID, and 002 will check where your DAG have a explicit schedule argument or schedule interval. If you are still using Airflow 1, which you probably shouldn't yet. So in this example, we have incorrect name and set task ID as my task. Ruff will tell you, just don't do it. You should set a variable name the same as your task ID. And 002 will tell you you should add an explicit schedule argument in DAG. And the reason why is before Airflow 3, the default value of schedule is daily, which is kind of unexpected, to be honest. So that's why we decided to remove it from Airflow 3. The default value of schedule is now none in Airflow 3, but because of this behavior change, we still suggest everyone to set your schedule to something. Even if set it to none, that's perfectly fine. Then let's go to the migration rules. For 301 and 302, they are required changes because if there's warning in your DAGs, that means your DAG cannot run in Airflow 3. So 301 is something removed from, or renamed it or moved to somewhere else in Airflow 3. And 302 are the ones that move from Airflow core to Airflow provider. So you probably need to install a standard provider other than just Airflow to use the original feature. And let's take a look. So for 301, we used to have a dags ago function, which is airflow.util.dags, but we decided to remove it because it's easy to implement through standard Python library. And 302, this is example we use fab of manager. It's used to exist in airflow.of.managers, but we moved it to the fab provider like long ago. So, and we decided to remove it in Airflow 3. And Ruff will also tell you which version of fab provider you should install. And then Airflow's AIR 301 and 312 are pretty much the same as their 301, 302 counterparts. The only difference is it won't break your code at this moment, but it might break your code like future release 3.1, 3.2. We are not sure when we'll remove the backward compatible layer, but yeah, we still suggest you to upgrade to the latest syntax. And for this one, like we renamed it dataset as assets per AIP 73. But if you still run from Airflow import dataset, it still works fine. But it's basically an alias from airflow.sdk.asset to from the dataset part alias to the asset part counterpart. So we still suggest you to use the new version. And this one is a Python operator. I believe almost everyone has the experience using it. It used to be in airflow.operator.python. We move all these kind of Airflow operator, sensors, hook from the core to standard providers. So now it's suggested to use airflow.provider.standard operator, Python operator. Yep. So let's take a look at what Airflow 3 something something rule can do today. We can check all the renamed, moved, removed variables, just as I demonstrated previously. But there are some cases related to class attribute, class methods as well. This can be checked. Like if you are implemented a listener, there's an on dataset changed, but it's now renamed as on asset changed. So Ruff will be able to warn you, hey, this method has been renamed and we can fix it for you. Also, function arguments. There used to be a schedule interval in DAG initial method, but it's now renamed to schedule. So Ruff can fix that for you as well. And Airflow plugin extensions, we used to be able to use operator as sensors, but it's not now removed and not supported because you can just use them as standard Python modules. And removed context key. If you are using Python operator, you probably have the experience to access the current context and try to get logical date, triggering a set event and something. But execution date is not a thing now. So if you are accessing execution date from context, Ruff will also warn you, you shouldn't do that as well. So yeah, there are some things we can do, these rules can check today. For example, the AR 201, it's not yet implemented. And there are some breaking changes. I do not yet have the bandwidth to actually edit them to the Ruff rules. And if you're doing this kind of attribute access, like from Airflow import decorator, and you use decorator.dag, Ruff will still be able to check and tell you this is wrong because we move dag to airflow.sdk, but it won't be able to fix it correctly. It will, if my memory is right, it will fix it into just dag from Airflow import SDK and dag. Then that will be an import error. It's a limitation for now, and we'll need extra effort to actually implement this part of logic. But I think it's not as common as it should be, so I defer this one to the future. And there's another case if you are actually using Python operator and you pass a callable as a argument of Python callable, this function won't be checked because there's a high chance of false positive we discussed with Astro team where we should add it, and we decided not to. So if you are using classic operator, yeah, this kind of context missing won't be able to be checked. But if you are using task flow with the task decorator, that's perfectly fine. And yeah, Ruff will tell you that has been removed and outdated. And what this kind of static analysis can do even like 3 years after now is this kind of dynamically generated code. If you are passing a variable as the argument name and you just pass it to dag, we are not able to analyze it because yeah, we are doing static analysis instead of runtime check. So this is not this kind of AI rule can do. So let's go into how it's done under the hood. So it's all started from TP. There's yeah, I know the font is really small. So it basically tells, should we use Ruff as the official linter to detect all the Airflow 3 incompatibility in user code? And the reason why we decided to use it as a community is mainly because the terminal user interface of Ruff is so good. Yeah, implement the logic to check. We can use Python AST, that's easy. Implement the fixing part, we can use another Python library, CST, that's also easy. We already have it in Airflow codebase itself to block some of the bad smell we don't want to exist in Airflow core. But to design the terminal user interface, it's not such easy. So we decided to leverage what Ruff already have. And NumPy also used Ruff to migrate their user code from NumPy 1 to NumPy 2, which is the NPY 201. And there was an existing Airflow rule. So communicating with the Astro team shouldn't be this hard. And it turned out to be really good. There are awesome people helping us to polish our Ruff rules. So how this is done is basically using AST. And what is AST anyway? It's an abstract syntax tree. It's a way for you to represent your Python code in a tree structure. And this is a minimum AST sample. If we have a source code A equal to 1 plus 2, and we can use AST to pass it into an abstract syntax tree. To better visualize it, I use AST dump so we can get a structure like this, and that's visualized this way so everyone can understand. So we first traverse into the assigned AST node, and then there's a target we want to store some value into the A variable. And on the value side, we'll have a binary operator with the left-hand side as the constant 1 and the operation add, and then right as the constant 2. So that's basically how we try to represent your Python code and traverse the whole abstract syntax tree to detect the behavior we don't want and try to manipulate this tree to add some of the fix we want. And under the hook, they also have a Ruff Python AST. So they implemented their own version of abstract syntax tree in Rust. And I think they also take a look at a Python standard library AST, but they extend more functionalities. And before we actually go into a checking example, there are some files we might care about when adding a new Ruff rules. So we talk about all those O1 or some error code like that that's defined in this Rust module. So if today I want to add an airflow 313, we'll add a line here, but the rule group will later be set as preview. They need like 2 minor version to become, these rules need 2 minor version to become stable. And then you'll need to refer to the new rule you defined. It could be airflow 3 something something. And then we'll need to register the logic we implement elsewhere into the AST node. Like the previous example, we try to do a equal to 1 plus 2. If we want to do magic here, we can register the logic in expression.rust. And that's going to be detailed a bit later. All our airflow logic, rule logic exists in this Ruff linter rules.airflow, like the dags schedule arguments and move imports in 3 and all these kind of things. Of course, we also need to add some unit tests to ensure our rule actually works as we expected. So let's go through the simplest example to see how it works under the hook. So we try to change the import from airflow.decorator import dag to their airflow SDK counterpart. So first we'll register the logic here. In this expression.py, we'll check whether this expression is a NaN and we try to load something. And we'll go through all the rule enable check and go through here. This rule airflow 3 suggested update is basically airflow 311, which is the airflow.decorator.sdk thing. Airflow.decorator.dag thing will try to replace it as airflow.sdk.dag. And this is the function we implemented in another module. We'll pass the expression AST node into this function. And inside this function, we'll check whether this Python module uses airflow. If not, then we'll just skip it. We'll assume it has nothing to do with airflow. And in this case, we'll check which kind of expression it is. The first one, check the arguments of your function code, and the second one, check the attribute of your class or your initiated object. The third one, just check the NaN you imported. So we later enter this function. And the first thing we do is we try to resolve the fully qualified NaN. By fully, we mean that you'll be able to get a full class path, and the qualified NaN means you'll be able to get the NaN it was originally implemented. So even if you import dag as not dag, you can still get the qualified NaN as dag. And then we'll try to split this airflow.decorator.dag as 3 different components as airflow, decorator, and dag. Then we'll add a lot of different cases to compare with it. So it matches airflow, decorator, and if the last part match the list here, then we'll generate a replacement object. So in this case, this is source moved to elsewhere, and where is the so-called elsewhere? It's airflow SDK, and whatever it matches, it will just turn that match thing into a name string. And then if there's no fix needed, like the days ago function we mentioned earlier, there's no replacement, then we'll will not generate a fix and did an early return here. And we also consider if the user is trying to do backward compatibility by themselves. So we'll try to check whether this statement or expression is guarded by try exception case like this one. So if user have this kind of structure, then we'll skip the check and we don't do any kind of replacement for this one. And this is almost the last step. We'll create a diagnostic. So this diagnostic is basically what Ruff tell you you shouldn't do you shouldn't do something and how you should fix it. So if you don't pass the fix flag into Ruff check, it will tell you airflow decorator tag is removed in airflow 3.0. It still works, but you probably should upgrade it to there's an airflow.sdk instead. And there's no set fix available, but there's some unset fixes here. So that's the diagnostic part. But before everything ended, we can set the fix to the diagnostic object. There are two kinds of fixes we already implemented in Ruff. So the first one is set fix. It's not applied to this case, but it's an easy one. So if the name itself is renamed like dataset to asset, or Python operator, if we rename it as Python something operator, it's perfectly fine to use set fix. So this set fix actually import a new name. So your Python module will have a new import from Airflow SDK import asset, and it will change the original dataset assets as asset. That's the second step. And the original import will just be left there, and other Ruff rule will take care of that, so it won't change anything. But for cases like this one, if you are using pig operator, it used to be in Airflow operator, but it's now moved to Apache pig provider. But the variable name is still the same. It's a bit more complicated because if you just insert a new import, it might shadow the original one, or the original one might shadow the new import, so it's not working. So we need to remove the original import and then import a new path. So removing the original import is a part being considered as unsafe by Ruff. But generally, it should just be fine. And yeah, that's it for the simplest example. And what's next? We already have the ability to acknowledge it to implement some migration rules, so we probably can implement best practices as well. If you are there for the DAG links thing, we have a discussion in this thread. What can be the best practice is we want all Airflow users to use. So if you are interested in this topic, yeah, please join us and share your idea with us. Okay, then yeah, I'm Li Wei, or Wei in English. I work for Astronomer, currently a PNC member of Apache Airflow, and other are some of the open source community I get involved. Yeah, it was just announced yesterday. And of course, there's a syntax error in the previous page. And there's something also announced yesterday, which is Python 3.14, if you are interested in. And that's why this Python actually works. Yeah, there's a T-string, free-threaded. Yeah,